So, welcome to another episode of Runtime Reverie. Today we've got Hot Take Patrick on expedition to the US. Where are you right now? Are you which state are you in?
I'm in Florida in the United States of America. It's first time to the US, and decided I should share my hot takes with the world. So.
And I think Craig might be away today, but maybe he might join us later. We'll see how that goes. And what's on the ticket? What's happening in Florida other than a major hurricane that may cause issues?
Yeah, the hurricane fortunately missed me. There's some flooding and stuff on the coast. It doesn't look that. Yeah, glad I'm sort of inland. I'm in Orlando. And missed all that. But the conference organizers are coming tonight, I think. And there's, I asked, and sounds like I'll be included in stuff like going to Universal theme park and other things that are around here. So haven't really been to a theme park. I'm not sure if what's the thing in Melbourne, the Luna Park. I'm not sure if that really, it's
that does not count. No.
Yeah, it's pretty scaled down. So go on one of these crazy roller coasters. Yeah, that'd be awesome.
Yeah, fantastic. So it's all about the conference there, right? What's the conference?
ElixirConf. So it's the 10th anniversary, and so Elixir is a programming language. I think has been out for about 10 years, and they must have had conferences pretty early on. So it's the 10th anniversary, and it's in this nice resort in Florida, and so I think they're going all out. So I think of all the ones to attend, I think I'm attending the right one. And it's like multi-track, so there's going to be like 3 stages, so it's going to be pretty full on.
Oh wow! So they probably have thousands of people attending.
I think it's pretty big. Yeah, I'm not sure how many people are attending, but I think it's pretty big. There's a lot of speakers. I think it might be like 80 speakers or something. And there's 3 keynotes. And the first keynote's on Monday, I think. And then I'm straight after in the same room after the keynote. So they've given him, there's like a little break, and then so they give me a really good slot. And so I feel like I have to deliver, but And
is your talk ready? Are you? Can you give us like a one-line teaser of what it's about?
I think the talk's ready. Probably needs another. I want to practice at least once more. The talk is on. Basically, I think WebAssembly is an area of interest. Not saying it's going to be like take over. I never go that far with anything like that. I don't think it's going to we're all going to be writing WebAssembly instead of whatever you're using today. But I think there's some unique properties. The fact that it can run on all the major platforms today, I think that's really compelling. And so I wanted to create I just call it a DSL, but sort of becoming a bit of a programming language to help author WebAssembly. So basically, looked at the WebAssembly spec, looked at this WebAssembly text format, and made a slightly higher version in Elixir that helps you, write these little WebAssembly modules.
Yeah, right. So it's actually you're writing in a DSL on top of Elixir.
Yep.
But it's compiling down to WebAssembly.
Yeah, I'm taking a bit of a shortcut. It just compiles down to this WebAssembly text format, which looks sort of like a Lisp or a scheme-like language. So I'm just spitting out a string of that format, and then there's a little utility that you can use in Rust or on the command line to convert that text format into the WebAssembly binary format. And if this thing gets some traction, that's what I'm hoping to see. I don't want to just be the only one running this library. I want to go hey, here's this thing, and then hopefully people in the community go oh yeah, that's solving I can see how this might solve a problem I have. So if that happens, then I'll invest more time in compiling directly to the binary format of WebAssembly. So yeah.
Yeah, that's awesome. Awesome. Okay, so I have to tell you what I'm excited about this week.
Yeah.
I'm really excited about Semantic Kernel. What the first thing you're going to ask is what is it? And it's I'll just try and draw analogies. There's other in the AI space, which is growing really, really fast and moving crazy fast every week. There's a few other tool sets, things like LangChain. I don't know if you've heard of LangChain.
Heard of it. Yeah.
No. So you would have heard of early days. There were things like AutoGPT. Did you hear about that?
Yeah, I wasn't really convinced by that. Things
really understood it. Well, there's this idea that you don't want to just a large language model by itself is just one piece of it, but there's a lot more you could do if you just tack on a little bit of extra scaffolding, right?
Yeah.
So in particular, what could you do if you had like a multi-step problem to solve, right? Yeah. Like a classic one is I want the model to write me a poem, but then translate it to another language.
Yep.
That would be a classic sort of problem, right? So that's actually two steps. There's a generation step, write me a poem about X, and then there's just a straight translation step, which is a totally separate thing. It's a separate problem. So there are, people start making these tool sets to combine multiple steps in a process and say, okay, well, step one, generate poem. Step two, translate poem to other language, right? And it doesn't have to be 2 steps. It could be 10 steps. It could be many. So things like LangChain were born. They also add other elements like memory, so you can store some information about what conversations were had and what previous things you've learned, and a variety of other things. There's another one that Microsoft's made recently. It's sort of like the enterprise version of something like that. It's focused on C# and enterprisey tool sets, and that their version is called Semantic Kernel. They said something really, really cool, and I think that just got me super excited about the future of programming and like what things could be. Like just as excited as you are about web development with WebAssembly, this got me really excited about just not traditional backend, but just general programming, right? Historically, all our programming languages, all the stuff you're working on and most people have ever done, we've done our careers, has been sort of in this, I guess, paradigm of syntactic coding. So you write some syntax which describes exactly what you want to the computer, right? I want you to do this step and this step and this step, and you're literally programming the computer to do a series of actions. What LLMs do is they allow you to describe something not using syntax but using semantics. So like you need to try and interpret something both to generate or to infer or find similar elements, right? And that's sort of like, if you think about it in terms of traditional programming, you might have a traditional native function and you might have then a semantic function, right? Okay. And so what they did with semantic kernels, they said, hey, look, just that same idea that you have pipelines of steps, just like you might have a pipeline in a web application or in a WebAssembly pipeline. We were talking about WebAssembly modules the other week. You have a pipeline of steps. In that, you might have native functions that do traditional native syntax-based actions. Compute. Yeah. But you might also have a step that is purely semantic compute.
Okay.
Right? And so semantic kernel lets you define both of these types of functions and merge them in. And not just into a pipeline, but into a planner, which decides, hey, which thing am I going to pick off the recipe list to achieve this end, and in what order?
Okay. Right? So it's almost like a scheduler, or
it's like a scheduler, except the scheduler is semantic. So you can you can leave it up to the scheduler to go figure out what sequence to pull these functions in, and which functions need to be native functions. So, for example, some functions need to be very deterministic, like what time is it right now? I don't want it to imagine the time. I want to know exactly what time it is now. What some date operation is, what like some, I want to see articles from last year. Well, last year is a very specific thing. It's not up to conjecture or interpretation, right? So that could be
deterministic.
It's deterministic. It's a deterministic function that you can define with very deterministic syntax. But then you could say, I want you to find articles last year that were about WebAssembly and Elixir.
Yeah.
Right. And there it has to use some semantic understanding of what those articles are to figure out what's about those topics.
My understanding of the current LLMs is that almost in opposition to the previous AI efforts where they tried to semantically understand the text. They tried to use linguistics and sort of say like, hey, this thing's a verb, this thing's a noun, and therefore when this thing is next to this thing, it's it's read, not read. Like even though they're both R-E-A-D, it like you had to sort of tell it, you had to sort of help it hold its hand doing that. And I thought the new LLMs were sort of just like almost just probabilistic. They sort of had no understanding of the content at all. All they could do is sort of just predict that given this token and this token, then this token is most likely to happen. Like they have zero semantic. So is that
it's not quite right. No, there's definitely, that's a simplistic version of it. There's much complexity. Yeah. So, but they do they know? I don't know if they know anything. That's a pretty loaded word.
Because that was the sort of big thing in I thought with like training was like, how do you kick off the like, can you just give it a bunch of data? Can you just give it a truckload of data, and we just have a terabyte of data? We get all of Reddit, all of Stack Overflow, all of whatever, scrape everything, and then just go good luck, and it just trains itself. Like I thought that was just one of the big breakthroughs, was that you didn't sort of have to go and hold its hand at all. You just sort of give it enough data, this thing could work out all the patterns and be like have a high enough quality output.
Yes, but there's lots of nuance under that. Okay. So you here's all the data from X. Okay. Then there's a pipeline which cleans the data, cuts it up into like bite-sized little pieces, the right size pieces, the appropriate overlap between pieces so that they can maintain context.
Oh, in terms of like the tokens.
Yeah, like
so the tokenization's like a key.
Well, not just tokenization, but you've got to actually chop it up into little pieces, and you've got to chop it up into the right size pieces, broken up at the right points. Then you've got to do that over and over and over, and then I'm sure there's even more complexity that I'm not aware of. So do they understand syntax? Semantics? Yeah, they sort of do because of the way they are presented the data and the groupings of the data is what I.
But it's all, I don't know the lingo, but there's some term of art for it. Like it's inferred, like it's sort of self-categorizing, isn't it? Like there's not a human having to go like this label, this label, this label. It's like it's almost just like given enough data, it works out what buckets to put things in, and sort of.
Yeah, and I'm not sure we're going to have time this week, but next week we'll ask me about embeddings. I'll tell you about embeddings and how they work and how the grouping and the similarity searches work.
So is the semantic kernel idea of like sort of creating this pipeline, is that like a key problem that people have found? It's hard to sort of wire all this stuff together. Like, is there efficiencies to be gained? Because like if you run like a chat GPT thing now, it gives you back the text version, like has to convert the text to tokens to do magic, like box, as in my understanding, what you just described. Then it gets tokens out the other end, then it turns that into text. Like, are you skipping that like tokens to text, text to tokens thing? If you got these two things, like it can just go tokens to tokens, like it doesn't have to sort of encode it and decode it. Is there efficiencies?
I'm not sure quite what you're getting at, but one concept here to think about is often you're looking up information, right? You're trying to find some answer. That answer, it's not about finding similar words sometimes. I mean, sometimes it is about finding similar sort of words or semantically similar meanings, but other times it's about very discrete metadata that you need to filter on, or you need to apply. For example, the date, right? Like I want articles last year. And so there, you need to combine different types of logic to get an output. Also, there's just the types of problems you can solve when you can chain operations is dramatically higher. The same thing, we were talking about this for WebAssembly, right? So if you can chain WebAssembly modules together to achieve an end, it's the same thing. So what we've essentially done here is we've said, hey, we're going to add another thing to the programming toolkit, right? Two big things. One is we're going to add LLM-based semantic planners that interpret your words and spit out a logical sequence of actions, right? And then the planner will then find the closest skill or thing, like function, essentially, whether it's a native function or a semantic function.
Like a SQL planner, sort of.
Very similar. Yeah. So go look in this table, then join to that table. So those planners now exist in this world. So, but not only do they exist, but they cross the bridge and they combine native and semantic functions.
Are they deterministic like a SQL plan? Like obviously, the SQL planner it's a bit of a black box, and you go, oh crap, just added this little thing and like plan something completely different. Like, is this thing like 100% going to give you the same plan every time, or is it going to be like, oh crap?
It's all configurable, and there's so many variables, and there's so many planners, and but
it's deterministic. Like, given if I plan something and then you plan something, we'll have the exact same plan.
Are the planners deterministic? Again, up in the air.
Okay. Because that's what it seems. With this AI stuff, like you have to have a bit of temperature for it to be the result to actually be interesting to humans.
Not necessarily. Depends what you're trying to do.
Okay.
Or for something like planning, you'd want to wind that down to 0.
Yeah. Okay. Yeah. Right. So sort of no randomness. Yeah. Right.
No. You don't want much of that at all, if any.
Cool.
Dude, I'm running out of time. I gotta jump in a second. I really want to talk about something else, which is the optimization.
I
think we'll get time this week. Let's put it on the docket for the next conversation, and let's see if we can get Craig in here, because he's going to have some hot takes for sure.
Yeah, that'll be interesting. Yeah, that will be good.
Because I think you and I will probably take the same side. We need someone to take the other side.
Yeah, okay. We'll take the sensible side. We need someone that we disagree with, whatever side that is.
Yeah.
But yeah, I enjoyed the AI chat. I might look into some of the stuff. It's obviously the AI stuff's just like massive, but moving quickly.
There's a great course that John Mader did. I'm going to link it in the show notes to you. I'd definitely recommend anyone who's interested in this stuff to go check that out. Especially if you're in the tech world and you can follow along. It's just brilliant.
Cool. All right. Well, that was a fun episode, and I'll chat to you next week.
Cool. Catch you later. Bye, everyone.
Right. See ya.